Yeah, so it's another day, it's another wonderful day. So I was just going through the post, and a lot of you were saying physics is hard, physics is difficult, and you are scared, you are confused, and all of that. Well, the key thing is you have to just be intentionally positive. So what you say is hard is hard. What you say is simple is simple. The moment you begin to tell yourself consistently that you can do this, you got this. Physics is simple, it's very clear, it's easy for me to flow with. The moment you tell yourself all those positive words every single day, not even about physics, any subject that you find difficult, you keep telling yourself that this course is achievable. I will conquer you. I have conquered you. You are very easy, as clear as day. Guess what? Your brain will begin to program itself and position itself to be able to assimilate that subject, and it will find the best strategy to ensure that you get it and you get it right. So I just said, let me quickly say that online, and then just press the syllabus for any the JAMB syllabus 2026, JAMB 2026 syllabus for any subject that you are working with, and then it comes up and you can easily use it, and it will guide you in your preparation for the um for the JAMB exam. So we are going to be looking at this first topic right here, which is units, that's measurement. So that's the first thing that we are going to be looking at, and everything that we right here, I'm going to try as much as possible to touch on it very, very brief as possible, and then we get into some questions, some practice questions to show that we have fully assimilated the course outline. So the key thing here is, you know my style. I will be using more voice note in explaining. So just get your writing materials, make sure you are penning down the key points, and and follow along. And when it comes to the practice questions also, just like we did yesterday, try as much as possible to attempt it and then grade yourself. All right, so let's begin with the introduction. In physics and science, there are certain properties of physical quantity that are considered fundamental and that are used as a basis to derive other quantities. So these are called fundamental quantities. They are measured using specific units known as fundamental units. So in the international system of unit, that's the SI unit, there are 7 fundamental quantities that has been identified. So you have the length, you have the mass, you have time, you have electric current, you have luminous intensity, and then you have temperature, and then you have amount of substance. So each of these quantities has a unique unit of measurement, and they are denoted by specific symbols. So the fundamental quantities are also the independent physical properties. So just like I said earlier, they are the main unique quantities. They are not derived. That's when you're talking about derived quantities. Derived quantities has to do with the fact that they are not independent. They are dependent on the fundamental quantities. So let me quickly state some of the units of the fundamental quantities. So for length, you have meter. For kilogram, that's for mass. Mass is measured in kilogram. And then you have time. Time is measured in seconds. Current is measured in ampere. And then you have the temperature, which is measured in Kelvin. You have the amount of substance, which is measured in mole. And then you have the luminous intensity, which is measured in candela. So those are the 7 main fundamental quantities that we have. And now let's move on to derived quantities. Right now, let's analyze what we called the derived quantities. So derived quantities are physical measurements that are derived from combination of the fundamental units like length, mass, and time using mathematical formulas. So they are essential for quantifying physical phenomena. So unlike the base quantities, which we also call the fundamental quantities, they are not independent. They are actually dependent. So you have common examples like speed. So when you're talking about speed, the formula for speed is distance over time. So inside speed, you have the meter and you have the seconds. So remember we said earlier that meter is for length and then seconds is for what? For time. So you see that speed is not a standalone. It is actually derived from the combination of length and time. And then you also have acceleration, which is meter per second square. That is also a combination of length and time. And then you have density, which is kilogram meter cube. the kilogram per meter cube. And you know, density is measured in the formula for density is mass over volume. So from the formula of density, you can realize that it is a combination of mass, which is capital letter M, and also a combination of the length, which is the meter cube, which is ml. So, and then you have force. Force is also another derived quantity. You have force is equals to mass times acceleration, and force is measured in kilogram meter per second square. So I'm going to send in a kind of like a picture that captures some of those different derived quantities and then the fundamental quantity, so that you will not be confused. You can see all the different derived quantities here and their what is it called now, and their dimensional analysis. And we are going to get into this dimensional analysis very, very soon. So I want you to familiarize yourself with all these dimensions that are shown here. So let's start from area. So you can see that area is length times width. So that is L times L. So the dimensional analysis, or the dimension for area, is L raised to power 2. Now, the unit for area is meter square. But when you're talking about dimension, you use capital letter L. The L there is representing length. You know, the unit of length is what? Meters. So don't confuse dimension with units. So there are some calculations that you are going to see later on when you start checking some practice sections with CBT. You realize that they ask more questions relating to the dimensions and than they will ask about the unit. So familiarize yourself with them. Now for volume, you have meter cube. So you have L times L times L. That's L raised to power 3. So you substitute the M raised to power 3, which is the meter cube, with the what's it called now? With the dimension, which is L. And then you have acceleration. You have acceleration is meter per second square. And the formula for acceleration is what? Velocity over time. So you can see here from the dimensions that it has LT raised to power minus 2. So LT raised to power minus 2, or it can be L slash T raised to power 2. So which means that the raised to power minus 2 there means that it is the length, that is the distance, all over what's it called now? That's the velocity, sorry, which is LT raised to power minus 1, all over the time. So just familiarize yourself with all of this, because in the next part that we are going to be looking at, we are going to be talking about some dimensional analysis. Thing we want to talk about is position, distance, and time. So when we are talking about position simply means the location of a particular point in space. So the location of a particular point in space is what you call position. And there are different ways where we can determine the position of a thing in space. So we have the rectangular coordinate, which many of you recognize as the Cartesian plane. So that helps us to recognize two dimensions. So you have the x-axis, which is actually the horizontal point, and then you have the y-axis, which is actually the vertical point. And then in 3 dimensions, we have introduction of another one, which is the z-axis. So the x-axis tells us the left to right, which is sideways, while the y-axis tells us from top to bottom, that is up and down, so vertical. And then the z-axis recognizes the front and then the back. So that z-axis is in introduction is introduced as a result of what's it called now? 3 dimensions. But when you are working in 2 dimensions, you only recognize x and y axis. But when you are working in 3 dimensions, you recognize the z-axis, which recognizes the front and then the back. All right. So now, talking about direction, what is direction? Direction is actually measured based on the north, the east, the south, and then the west. So that's a compass bearing, and you recognize that you read from the north. So when I say you read from the north, it means you read from the north in a clockwise direction. You know, time is actually read in a clockwise direction. So you read it the north down to the east, down to the south, and down to the west. Let's read in here. You see that the reading begins from the north, and then it moves from the north at 0 degree, and then moves the northeast. That is the one that is the northeast, is what the point that is in between the north and the east, and that is 45 degree, and then it moves to the east, which is 090 degree, and then southeast 135 degree, that's in the point between south and the east, and then it moves to the south, which is 180 degree, and then it moves to the southwest, which is 225 degree, which is the point between the south and the west, and then it moves to the west 270 degree, and then it moves to the northwest, which is 315 degree. That's the point between the north and the west, and then it finally gets back to the north, which is 360 degree. So that reading is called clockwise direction. So you will need this understanding later on when calculations are done in vectors, because vectors are actually quantities that have magnitude and direction. And remember that what we are talking about here is actually talking about direction. So you can't talk about direction without understanding this compass bearing. So that's the reason why I had to send you the sketch, so you have an understanding of what I'm talking about. So let's move on to the next point, which is distance. Right, so when we are talking about distance, so distance has to do with the length of something from one point to another. So there are different ways you can actually measure distance. You can use a kind of like a string or a rope to actually measure a distance. But although if you use a spring, you still need to bring that rope near a meter rule to be able to get the correct and accurate reading. So that brings us to a meter rule, and a lot of us knows what a meter rule looks like. A meter rule is actually a ruler. So in physics, we call it a meter rule, and it is calibrated from 0 to 100 centimeter, depending on the length of the meter rule. So we use it to measure the length of a book or the length of a table. And then you have the Vernier Calipers, which is the diameter, is used to measure the diameter of a cylinder or the thickness of a coin. So you use a Vernier caliper to measure something that it is impossible for you to use a meter rule to measure. So imagine you can't use a meter rule to measure the diameter of a cylinder. So let's say the bucket you have in your house, or let's say the 3 crown milk. How do you intend to use a ruler to measure that accurately? So that's when you use a Vernier caliper. Or when you want to measure the thickness of a coin, you use a Vernier caliper. And then you also have the micrometer screw gauge. So the micrometer screw gauge measures even something smaller than the Vernier caliper. So when you want to measure the thickness of a paper, and many of you know how a paper looks like. So imagine you want to measure the thickness of it. How thick is the paper? A ruler cannot do that. A Vernier caliper can definitely not do that. So you use a micrometer screw gauge. Or you want to measure the diameter of a hair strand. When I say a hair strand, what do I mean? A hair strand is like your hair. So imagine just one strand of your hair. You want to measure it. Can you measure that with a ruler? Can you measure that with a Vernier caliper? No. You use a micrometer screw gauge. I'm still going to show you how you can actually read accurately, because there are a lot of questions that comes on you being able to read accurately. I mean, they'll show you a diagram of a micrometer screw gauge or a Vernier caliper and ask you to get the accurate reading. So I'm still going to get to that. I just want to get on first with the theory before I go into all of that. So the Vernier caliper, it is generally capable of measuring accurately up to 0.05 millimeters. So the accuracy range of a Vernier caliper is 0.05 millimeters. And why for a micrometer screw gauge, it is 0.01 millimeters. So you need to take note of that very, very important and crucial point. Whereas a meter rule has its accuracy up to within 1 millimeters or 0.1 centimeter. So I take it again. Meter rule is 0.1 centimeter. Vernier caliper is 0.05 millimeters. And then you have the micrometer screw gauge, which is 0.01 millimeters. To differences between distance and displacement. So when we are talking about distance and displacement, I'm going to show you a picture after this voice note that shows you the clear-cut differences between distance and displacement. But for the sake of explanation, simply put, distance and displacement have the same unit. That's their similarity. They are both measured in meters. But when it gets down to the real thing, distance is a scalar quantity. So when you say a scalar quantity, it means it only has magnitude. So you can only know the amount. So for instance, now if Tunde travels from Ibadan to Abuja, and then the distance that was covered was 5 kilometers. So that's the magnitude, 5 kilometers. I know that it will be more than 5 kilometers. I'm just giving an instance. So let's say like 500 kilometers or 1,000 kilometers. So that's the only thing that distance tells us. It only tells us the magnitude. How far was the distance? How far was covered? But when you are talking about displacement has to go further into telling us the direction. So you can hear something like this in displacement. It traveled from Ibadan to Abuja at 500 kilometers due east, or 500 kilometers due north, or 500 kilometers due south, or 500 kilometers northeast. So if you hear northeast, maybe they will put a value there. So it could be something like maybe 45-degree northeast, or you will hear something like 135 degrees southwest. So when they put all those information, that is displacement. That value I just put, that compass bearing I just put, is what makes displacement very, very different from distance. What are the differences between mass and weight? The main difference between mass and weight, again, lies in their definitions and their units. So mass is the measure of the amount of matter in an object and remains constant. So mass is always constant. While weight depends on the force of gravity and varies depending on the object's location. So for instance, on the earth, we are being affected, the weight is being affected by the force of gravity. But outside space, you have what we call the phenomenon called weightlessness. So weightlessness is a state whereby when you are outside space, outside Earth, because gravitational force only affects us while we are on Earth. So when I say gravitational force, what do I mean by that? It means that when you throw something up, it comes down. It is the gravitational pull on any object on the Earth that makes anything you throw up comes down. And many of you may be wondering that, okay, if anything you throw up comes down, why is it that it is not affecting aeroplane? That's another discussion for today. That's not for today. So, but you can go ahead and make that research if probably you don't know about that. So, but when you are outside the Earth, you are in space, there is what we call weightlessness. So weight only has significance or value when you are on the Earth because of the gravitational pull on it. So weight is a vector quantity because it is based on the direction. You know what I said earlier about vector. Vector quantities are quantities that have magnitude and they also have direction. But when you're talking about mass has no direction. Mass is just mass. So if you go ahead and check your mass, your mass is 35 kilograms or your mass is 100 kilograms. That is all about it. So but weight is measured in Newton. So the formula for weight is mass times acceleration due to gravity. So that's W equals to mg. All right, and then finally, let's talk about the final thing, which is time. I'm trying to follow along and walk along with the syllabus that we posted earlier. So before I go about time, so how can we measure mass and weight? So the appropriate instrument that we can use to measure mass, you have the lever balance, you have the chemical or beam balance. Those are the things that you use in measuring mass. But when you want to measure weight, you use what we call the spring balance. All right, talking about time now. So time measures the interval between physical events. It is a continuous progression of moment measured in seconds using clocks. So time intervals are essential for understanding the order and duration of events in various scientific experiments and real-life scenarios. So time interval actually helps us to understand how long a particular thing takes. So the duration of something, that is what times help us to understand. So what are the ways you can actually use the various devices that can actually be used in measuring time? You have the stop clock, and then or what we call the stopwatch, and then you have the pendulum. So many times pendulum experiments are always used to actually determine time of a particular thing. So that brings us to the end of what we have to cover right here. Take a look at this Vernier scale that is here. So I want to explain to us quickly. In case if you didn't get it at the first time, just listen to the voice note over and over and you will get it. So if you take a look at this particular Vernier scale that is actually right here, you will see that you have what we call the Vernier scale, and you have what we call the main scale. So the main scale is actually the scale that you're actually seeing that is at the top, while the Vernier scale is the small stuff that is under. So the first thing you need to do when you want to take the reading is you see 5 there. So from that 5, you will count from that 5, and then the next value after that, the next line that after that 5, you call it 5.1, and then the next value after that 5.1, you have what we call 5.2. So now if you count, I'm talking about the 2 lines that you are seeing immediately after 5. So 5.1 and 5.2. Now once you get to that 5.2, you stop, because you realize that the next line that is after that 5.2 already has the Vernier scale under it. So you have to count, first of all, the reading. The reading on the main scale is the reading before the Vernier scale, and that is 5.2 centimeters. You note that down. And then you go ahead and look at the reading on the Vernier scale where the 2 scale intersect. So you look under the Vernier scale, you look at a line that intersects from the Vernier scale and also intersects with the main scale. And if you do the counting very well, you see that number 6 after number 5 that is in the Vernier scale is the one that has that coincides with the main scale, and then you divide that value by 100. So the first reading that I have taken is 5.2 centimeters, which is the reading of the main scale. The second reading is the reading of the Vernier scale, which is 6 divided by 100. That gives you 6 over 100. So if you add the two together, that's 5.2 plus 0.06, and that gives you the answer. So explain for the micrometer screw gauge. So the micrometer screw gauge is also is more or less closer, but it's just a little different from the Vernier scale reading. So the reading on the main scale, now as you can see from this diagram, you will see the scale that is aligned to the left that has millimeter written on it, and you see the other one that is aligned at the right that you are seeing calibrated 15, 20, 25, 30. So all those 15, 20, 25, 30 are the micrometer screw gauge, or what you call the Vernier scale. Also, there's also a Vernier scale in the micrometer screw gauge, and then the main scale is the one that is showing 0 millimeter. So now the first thing is you read the reading first on the main scale. Now for this one, now you read all the readings that is actually on that main scale, starting from 0. So you have 0, the small lining under is 0.5. The side where you have the millimeter mm is 1, and then the lining under again is 1.5, and then the other one again is 2, and then the lining under is 2.5, and then the next one again is what, 3. So you are counting 0, 1, 2, and 3. So that's the length that you have on the main scale. That's 3 millimeters. And then on the Vernier scale, you are going to look at the point where the Vernier scale coincides with the Vernier scale on the micrometer screw gauge coincides with the main scale, and you can see that actually happens at number 21. So if you look at 20, after 20, and then the next thing is 21, you see that line 21 coincides with the main scale that is at the left. So if you that particular Vernier scale, which is 21, you are going to divide it by 100. Remember that when we were talking about the Vernier scale also, under the Vernier caliper, we divided that value by 100. So this one too, you are dividing it also by 100. So that's 21 divided by 100, that's 0.21. So when you add the 0.21 plus the 3, you have your value, which is 3.21 millimeters. So you take 1, 1.1, 1.2, 1.3. So it's 1.3 you have here. And then that's for the main scale. So the main scale is 1.30 centimeters. You note it down. And then you look for the point of coincision. So the point of coincision after 5, you have 5, 6, 7, and 8, and 9. So that 9 is divided by 100. So that's 0.09. So 1.3 plus 0.09. The answer there is 1.39 centimeters. So your answer there is 1.39 centimeters. The following set of quantities is fundamental, of course. Length, mass, and time. So the answer is option C. Following unit is derived. So the answer there is Newton. That's D, because Newton is the unit for force, and force is a derived quantity. That's kilogram meter per second square. Location of a point or an object in space is called position. Position. What is the SI unit of temperature? That's Kelvin. Kelvin. Following physical quantities are derived. So from the options, area is derived, density is derived, pressure is derived, mass is a fundamental quantity. So your answer is 1, 2, 3. Option C, 1, 2, and 3 only. following is true of displacement. So from the differences I showed you earlier, I told you that displacement is a vector quantity. So because it's a vector quantity, it can be negative. So the only thing that is true there is option C. Is option A, because they wrote here that it cannot be negative, and it can actually be negative. It does not include direction. It actually includes direction. It is a scalar quantity. No, it is a vector quantity. So the answer there is A. It does not depend on the path traveled. Micrometer screw gauge reading. So this is how you read it. Is 5, 5.5, 6, 6.5, 7, 7.5. Let me go again. 5, 6, 7, 7.5. There is a small line that is under there. That is 7.5. So you'll note it down, 7.5 plus, let's look at the point of coincision. The point of coincision there is at the number 24. That is under 25. You see that number 24 there in the Vernier scale of the micrometer screw gauge is coinciding. So that is 0. You divide by 24 by 100. Divide 24. So that will be 7.74. So that's 7.5 plus 0.24. That's 7.74. 7.74 is the answer.